Geniuses, I'm back with another lesson on analytical geometry. I'm Deolan, and in this lesson we will learn about distance, midpoints, and the angle of inclination of a straight line. By the end of the lesson, you'll be able to calculate the distance, midpoints, and angle of inclination. Now, let's shoot straight to it. In our previous lesson, we learned about gradient and two standard forms of the straight line equation. Today, we will be dealing with calculations. To start with, let's talk about the distance. When we calculate the distance, we are calculating the length between 2 points in the line. The equation is distance squared equals bracket into x2 minus x1 bracket squared plus bracket into y2 minus y1 bracket squared. Let's do an example, shall we? Find the distance of these points, A3 map 7 and B5 map 2. First step, you have to label each point so that you won't make any mistakes when calculating. x1 equals 3, y1 equals 7, and x2 equals 5, y2 equals 2. The equation is ab squared equals bracket into 5 minus 3 bracket squared plus bracket into 2 minus 7 bracket squared, which is ab squared equals 4 plus 25, which is ab squared equals 29. To remove the square, we will square root on both sides of the equation, and we will have the square root of ab squared equals square root of 29. Therefore, ab equals 5.39. Let's do another example. P, -1 map 7, and Q, 3 map -1. X equals -1, y1 equals 7, and x2 equals 3. y2 equals -1. Determine the length of PQ. This will be PQ squared equals brackets into x2 minus x1 brackets plus brackets into y2 minus y1 brackets, which will be brackets into 3 minus -1 brackets squared plus brackets into -1 minus 7 brackets squared, which will be PQ squared equals 16 plus 64, which will also be PQ squared equals 80. And to remove the square, we will square root on both sides of the equation. And this will be where the square root of PQ squared equals square root of 80. Therefore, PQ equals 4 root 5. Now that we know how to calculate the distance, let's talk more about midpoints. The equation to calculate the midpoint of a line is midpoint equals x1 plus x2 over 2 map y1 plus y2 over 2. For example, find the midpoint of line RS, where R 5 map 6 and S 1 map -2. Now, as always, make sure that you label the points where x1 equals 5, y1 equals 6, and x2 equals 1, y2 equals -2. Now let's calculate the midpoint of line RS equals x1 plus x2 over 2 map y1 plus y2 over 2, which will be the midpoint of line RS equals 5 plus 1 over 2 map 6 plus -2 over 2, and that will be RS equals 3 map 2. Therefore, the midpoint of RS is 3 map 2. Note that a midpoint is a point that has an x value and a y value. Now let's talk about the angle of inclination, which is an angle that the line makes with the positive direction of the x-axis. To calculate the angle of inclination, we will say gradient of a line equals tan theta. Let's do an example, shall we? Find the angle of inclination, given 2 points, A, 4 map 3, and D, -4 map 11. Now note that to find the angle of inclination, we must first find the gradient of the line AD. You know how we do it? Before calculations, we have to align the values. x1 equals 4, y1 equals 3, and x2 equals -4, where y2 equals 11. Gradient AD equals y2 minus y1 over x2 minus x1, and this is gradient AD equals 11 minus 3 over -4 minus 4, which is 8 over -8. Therefore, the gradient of line AD is -1. Simple. Now that we have the gradient of the line, we can find the angle of inclination, and this will be gradient AD equals tan theta, which is -1 equals tan theta. To find theta, we will have theta equals shift tan -1, and theta is equal to 180 minus 45, which is 135 degrees. Therefore, the angle of inclination of line AD is equal to 135 degrees. Now we know how to calculate the distance, the midpoints, and the angle of inclination. Let's do another example. According to diagram 1 displayed on the screen, where a -1 map -2 is the midpoint of line CD with D3 map 6. Note that line BA is perpendicular to CD. Now let's calculate the following together. 1. The gradient of line AD. 2. The gradient of line BA. And 3. The angle of inclination of line CD. Let's do it together. 1. The gradient of line AD equals y2 minus y1 over x2 minus x1. We will use the given coordinates. Let's align them. x1 equals -1, y1 equals -2, and x2 equals 3. y2 equals 6. Now plug in these values into the equation. The gradient of line AD equals 6 minus -2 over 2 -1. Therefore, the gradient of the line AD equals 2. Now, let's calculate the gradient of line BA. Note that the coordinates of B, 0 map 0, and we are given the coordinates of A, -1 map -2. So let's align the values. x1 equals 0, y1 equals 0, and x2 equals -1, where y2 equals -2. Now plug these values into the equation. The gradient of line BA equals -2 minus 0 over -1 minus 0. Therefore, the gradient of the line BA equals 2. Got it? Great. Now let's calculate the angle of inclination of line CD. Remember, the equation of the gradient of CD equals tan theta. Now we have to first find the gradient of CD, and then we will be able to calculate the angle. Before that, note that we are not given the coordinates of C, but we can find them using the midpoint formula because we are given the midpoint of line CD, which is a -1 map -2, and we have point D3 map 6. So the midpoint of line CD equals x2 plus x1 over 2 map y2 plus y1 over 2. We will calculate these values separately, starting with the x value. This will be -1 equals x2 plus x1 over 2, which is -1 equals 3 plus x1 over 2. And we will cross multiply and get 3 plus x1 equals -1. Therefore, x1 equals -5. Now we can calculate the y value, and that will be -2 equals 6 plus y2 over 2, and we will cross multiply once again and get -4 equals 6 plus y2. Therefore, y2 equals -10. Now we have the coordinates of C, -5 map -10, which means we can now find the gradient of line CD, which is the gradient of CD equals y2 minus y1 over x2 minus x1. And that will be the gradient of CD equals 6 minus -10 over 3 minus -5. Therefore, the gradient of CD equals 2. Now that we have the gradient, we can finally calculate the angle of inclination of line CD. And this will be a gradient of CD equals tan theta, which is 2 equals tan theta. And theta equals shift tan 2, which is 63.43 degrees. I have a question. Did you get that? Well, that's awesome. Well done. I know that was a lot to take in, but let's summarize. We learned how to calculate the distance, the midpoint, and the angle of inclination. We also learned how we can use the midpoint formula to find the missing coordinate of the point on the line. Also, in order to find the angle of inclination of a specific point, it's very important that you find the gradient of that specific point. We've come to the end of analytical geometry. Now I know you might be happy, but you still need to be sure to continue practicing at home so we can get you those A's. I'll see you in the next lesson. See you soon!